So I start with initially with modal analysis. Okay. So I just give the job name as modal 1. So I'm working with APDL and then I click on run. Okay. So we are going to solve modal analysis. Okay. So what are the problems we have solved? So we are going to follow the procedure. I don't know the answer. You could verify. I'll tell you a few things about the answer. There is going to be, it might be possible that there may be a difference, but still you can verify it. Because exactly one-dimensional element we are not using, we'll be using a 3D spar. So it will be three-dimensional element. Okay, and the remaining side constraint we are going to fix it, so it will work as a 1D, but that doesn't happen very often. Okay, so you might get a closer result and you could verify it. So I go up preferences, I specify a structural analysis. So this is going to be my structural analysis. Then I click on preprocessor, then I click on element type, and then I keep the adding the element. So I'm going to add only one element, add. I'm going to add link 3D finite STN 180. So it is a 3D spar element actually, link 180. Okay. So there will not be any kind of option changes. I just close it. Okay. Then I go with the material properties. Okay. And then I go with the material model. Structural, linear, elastic, isotropic. So I specify 2E5, that is my modulus of elasticity, and Poisson's ratio to be 0.3, and click OK. So this is how the material is created. But we also require density to be specified. Till now, what are the problems we have solved? We haven't specified the density. So here in this case, below the nonlinear, there is a density option. So you have to click on this density, and then density you have to enter 7800 e raised to -9. So it is in kg per mm cube. Okay, because I enter the modulus of velocity in Newton per mm square. So therefore density I will enter as a kg per mm cube. Okay, and then I will click OK. So this is the only one thing addition as far as material property is considered, and then I will close it. Then I will go to section. In the section, I will click a link and then I will add the section. So section ID will be 1. Okay, first section I am going to add. Let's name the section as also 1 and link area to be 100 mm square. I click on apply. Okay, now I change the material section ID to be 2 and then click OK. Section name 2 and let's change the area to be 50. So I have two sections now. First section with 100 mm square and the second section with 50 mm square. Okay, so this is what I have done. Now I go to modeling, create, and I'll create nodes on active coordinate system. So my node number will be 1. So my first node number I'll put it at 0, 0. Apply. My node number will be 2 and my second node number will be 1000 comma 0. Apply, and my third node would be at 2000 comma 0, and then finally I will click OK. So you could see 1, 2, 3. So such 3 nodes are created. Okay, so now let's draw first element, which will be having a section of 100 mm square and the second element having a section of 50 square. Okay, the similar problem we have solved it. Then I go in elements. First of all, I just check the element attribute. So I want link 180, material number 1. So both are having the same material. So therefore I did not create another material. Section will be 1 because its ID is 1 and its name is 1. So that is what I wanted. That is 100 square. I click OK, and then I click auto number through nodes. Okay, first node, second node, and then I will click on OK. So this first element is created having a section ID 11 whose cross-sectional area is 100 square. Now again I go to element attribute, and here in this case I change the section ID to 2. So my section ID has been changed. Now I will select auto number through nodes. I will select node number 2, node number 3, and click OK. So in this way second element is created and it is having a cross-sectional area 50 square. So that is what I have done. So my modeling part is completed. Okay, I'll directly go into loads. In loads there is a 3 option analysis type. So we haven't changed this because by default analysis is static structural analysis. So initially in preferences we define to be structural, and in analysis type by default is static analysis. Now here in this case we are going to change because we are going to do the model analysis. So I go here and click on new analysis. So by default static is selected, so it becomes a static structural. Now I want to do a model analysis, so I select the model analysis, click OK. Once that has been done, okay, there is a something called as analysis option here, so that I need to go and select it. And here in this case I'm going to use block line cost method. Okay, number of mode to be extracted I will provide 6. Okay, so since this is being a 3D element, okay, so I just ensures that the on all directions the nodes are there, at least my mode shape is created in 2D. So that is why I am saying the modes to be extracted 6. If you specify more, if it is applicable, let us say 2 or 3, something like, so it will create some of the mode shape as 0, 0. Okay, so there is no issue specifying the higher value, but to reduce the computation time, I just specify the number of modes to be extracted to be 6. Okay. Okay. Start frequency and the end frequency I put it as 0, 0. It's no issue, you can keep as a default. Okay, and I want the normalized mode shape. So if you remember, we have gone with the orthogonalization of our eigenvector with the mass matrices. Okay, that is what we called as normalization. Okay, so orthogonalization of our eigenvectors with the mass matrix. That is what it means, normalization. Okay, and to whom? It is to mass matrix. Okay, you could have a unity, but generally it is to a mass matrix. Okay, then I go to the define loads. I say apply structural displacement on nodes. I select this load, first node, which I am going to fix it, and select all degree of freedom, and its value will be 0. If you do not specify, its value becomes automatically 0. Okay, so you could see it is fixed now. Now what remains is the solution. So I go to solution, okay, solve current LS. That is the only thing what is remaining. So I say OK. Okay, so now my solution is done. I close this Okay. Now what I go in a general post processor. Okay. Now, first of all, I need to read the results because there will be many values of lambda. Okay. And I need to select the particular value of lambda, and for that I need to plot the mode shape. Okay. So therefore, mm, in read result, I click on read result because I need to read that particular set for which lambda you want to perform the post processing operation. So that result I have to read it. Okay. Here by pick option is there. You can go with the first set, next set. In this way also you can do it. But I go with the by pick, so I can select the particular lambda. So when I click on pick, so I am available with various lambdas value. So these are the frequency value which is available with me. So I can select this value and then I select on read. Once I have done that read, I will just say close. Now I go with the plot result. So I click on plot result. I click on deform shape. I click deform plus undeform. So both the shapes I want it because I want to see a mode shape. So I click on deform plus undeform. I click OK. So you could see similar type of graph mode shape we have achieved by solving it. Okay. So just don't bother about it is above or below. It doesn't make any difference. Okay. Because what we do there, we take it as a u equal to u3 equal to in terms of u. Okay. It is also possible minus u3 is equal to in terms of u. So above or below it doesn't make any difference. So it's just the way it is going to, or from which direction you are going to visualize, that is also going to make a difference. So it shows the one of the mode shape. So it is on upper side or lower side, it doesn't make any difference. So we have got in upper side, but here in this case we got at the lower side. So similar sort of mode shape what we have received it. Okay, you could later on click on and query the result of this one. Okay, now I go with the read result again. I go with the by pick, and then I can select the second value of omega lambda. I can say read and close. Okay, now I can say plot result. Okay, deform shape, again deform plus undeform. Okay, so similar kind of shape also we have received. Okay, but it was actually mirrored one, so it doesn't make any difference. Okay, just like I say, u3 in terms of u2 we have calculated, assuming u3 coefficient positive 1. Okay, you could assume the coefficient of u3 to be minus 1, and then you could have a in form of u2 because it's a numerical method which is solving. Okay, so the coefficient whatever we are going to get is through program. Okay, so it's not that manually we say we make a left hand side positive and right hand side whatever the value comes. Okay, it is likely possible while solving. Left hand side could also come negative and right hand side in other form it could come positive. So in this way we could also we can easily do the mode shape. I have shown you how to find the mode shape using 3D path element. You can use any beam element, you can use any kind of planar element, any element, but the analysis remains the same. It is not going to change. This process is going to remain the same. Okay, and only what is going to change according to type of your analysis, whether you are performing beam analysis, whether you are performing 2D analysis, your element type and your geometry is going to change. Okay, now there are few other results also. So those results is going to come because what already I have said, it is a 3D element. Okay, so this is supposed to be a straight line. So I just confirm it, deform shape. Okay, so you could see it is a straight line. So it has not got a meaning. So it is a stage of longitudinal vibration. Okay, that we are not taking into consideration along the axis. Okay, so that's what we haven't taken. You could also list the result. Okay, whatever you want. Okay, you can also query the results also. That's fine. So you can find out the value on the graph which you are giving by having a nodal solution, and you can check out degree of freedom, displacement vector sum. So you could get the all the displacement vector sum. Okay. So for example, let us say if I go with the plot read result by pick this one, read, close, let's plot it. Okay, and then I can list result, nodal solution, displacement vector sum. So you could get it all these values. Okay, so this is for ux, uy, these values are there, you could verify. So this third dimension value is going to come. Okay, because it is a 3D spar element. So you have to consider one of the direction values. Okay. So just let me know whether you have understood this, or if you have any question you can ask. So just let me know whether you have understood it, or if anyone has a question you can ask. Is I audible? Okay. So now let's solve just one more problem. So what I do, I just clear this. Okay. So I just quickly go through it. Preferences, structural, preprocessor, element type add, linked 180, then material properties, material model, structural linear, elastic isotropic, 2E5.3, density 7800, E minus 9, close, section, link section, add 1. Okay, then I create section name term 1. Let us say first section is 100. Okay, second section, okay, second section, let us say 75. Okay, apply. Third section, okay, ID third section, let's consider area to be 50 and then click OK. So 3 sections I have created: modeling, nodes, inactive coordinate system, 1 for 0, all 0. Apply to 1000, 3, 2000, and finally 4, 3000. Okay, so 4 nodes have been created. Element attribute. So first section is of 100. Fine, no problem. 2 nodes, first and second. Okay, change the element attribute, change to section 2. Through nodes, second and third. Element attributes, section number 3. Through nodes 3 and 4. Okay. Okay, so modeling done. Loads, analysis type, view analysis, model analysis, define load, displacement, on nodes, select this and this. Both I am selecting, first and the last. Okay, all degree of freedom lock to 0. So that's done. Go to solution, solve current LS. Okay. Sorry, yeah. Analysis type, analysis option, number of modes to be extracted, 6, Nagoshe method. Okay, solve current LS, close, solution done. Then I go to general post processor, read result by pick. So I can select this one, read, close, and then plot result, deform plus undeform. Okay, so this is going to be my shape. My model shape is going to be like this. Okay, I can go with the read result by pick. Second result I will read it, and then I can plot the result, deform plus undeformed shape, and this is what is my second mode shape. So in this way, the 2 mode shapes I am going to get it. Okay, so this is the way you have to do it. Okay, so now let's move to the elastoplastic analysis. Okay, so I just clear preferences. Sorry, I just need to clear. Okay, so I will just clearing. Click on preferences, structural. Okay, so elastoplastic analysis is only about material. The way you do the all the other processing for performing the analysis of whether for 1D, whether for 2D, or whether for beam, or whether for the truss, it remains the same. There is no change. What is going to happen, that I am going to specify only the material, that this is what is the behavior of material, that is this is elastoplastic behavior. Okay, so that is what I am going to specify. Rest of the things remains the same. So preprocessor, element type, add, let's add solid. Okay, 4 node quadrilateral element. Okay, I check the option. I set the plane stress width and thickness, and then click OK. Close. I click on real constant, add. So let's add the thickness to be 10 mm. So I'm going to draw a plate with a hole whose thickness is 10. Now I go with the material properties, material model, structural. Okay, now it's not linear. Okay, it's elastoplastic. So therefore I go into non-linear. Non-linear, it is inelastic. Okay, then rate independent and kinematic hardening, and then Mises plasticity. In Mises plasticity, I go with the multilinear. Okay. So here I specify material properties 2E5.3 as a Poisson's ratio. Okay. So now I just show you what I did here. So it is non-linear, it is inelastic, it is rate independent. Then I am using a model called as kinematic hardening plastic model. Then in that I am going to use the Mises plasticity, and I'm going to use multilinear general. Okay, so general means you can add any more number of values, and when you say fixed table means you have to specify that this is going to be the size of my table, and that is what it is going to be have. Okay, so you might take a screenshot. Again I repeat, non-linear, inelastic, rate independent, kinematic hardening plasticity, Mises plasticity, multilinear general. Okay. Now what it means that general means I can add the points. So I just keep on adding it. So it keeps adding it. So how many I have added? 17 add, 19 add. Okay, so 20 points I have added. So it is blank presently. Okay, now what is going to be this? I will tell you. Okay. So basically what happens, many times whatever the analysis we are doing analysis with the help of Hooke's analysis. Okay, that is stress is proportional to the strain. Okay, up to a proportional limit. So that is what we are doing. But in many scenarios, sometimes this relationship does not hold true. Okay, especially after the proportional limit. Okay, or you could say after SYT and SUT. So this your Hooke's law does not exist. It is not a valid law in that case. In plastic material also, your Hooke's law does not obey. Okay, it does obey up to certain limit, but that limit is very small. In rubbers, okay, so these are all different things. Maybe you buy some other material which is non-homogeneous. Okay, maybe composites. So they will not behave according to Hooke's law, or if it is, but that range might be very small. So what you can do, you can take down the sample of that one. In second year, you might have studied strength of material. Okay, in that you might have gone through practical of tensile test on UTM machine. I don't know how many of you performed actually, but there is a machine, UTM machine, where on which we can perform tensile test. Okay, so what happens when that particular material, you make a rod of that and you apply the load and you get strain versus stress data. Okay, and finally that material gets fractured. So up to fracture you get a whole curve. Okay, and that curve data now you can utilize in ANSYS, okay, to perform the stress analysis. So exact material behavior will be exhibited while you are doing in a ANSYS. Okay, so here I am doing elastoplastic. Okay, it could be some unknown material. So you could go with the maybe some elastic material, and you could also provide these values. So these are some strain and stress values which I got from the internet. Okay, this is not I have tested. I got from this internet value, and with the help of those I have prepared the table. Okay, so this is left hand side I have the strain, and on the right hand side I have the stress. And if I plot it, strain versus stress, so on x-axis it is a strain and on y-axis it is a stress. So you could see this is what is the behavior of my that particular elastoplastic material. I could see up to around 300 or 350 MPa at this point, it is obeying the Hooke's law. But beyond that, it's not a Hooke's law. Okay, it is a purely a inelastic properties exhibited by that plastic material. So this whole behavior, we are going to use it to perform the analysis. So this is what all about elastoplastics, that is assigning a material. Rest of the things remains the same. So let's assign this. So I just copy this, Control C. Do not use right click and copy. This is not going to work in case of ANSYS. Okay, so you select this and place Control C to copy from Excel. Okay, and then here you select and press Control V. Right? Just a moment. I need to select the cell. Okay, and then Control V. What has happened? Okay, so in this way I need to select the cell. So cell is still selected as blue color, and then press Control V. If I does that, all the values from the Excel which gets copied here. Here 20 values was there, and therefore I created a 20 data points. Okay. Similarly, I just select this, press Control C, then select this whole cell. Okay. So you have to move the mouse in a such a way that such pointer will appear, and then you have to click. And then press Control V. So all corresponding stress value has been appeared. Okay, so that's the only stuff about the elastoplastic. So I close this. Okay, now where is my ANSYS? This is ANSYS. So my material model has been done. Okay, now I go with the modeling. I create area, rectangle by two corners. Which is 0, 0, width might be 100, let us say height also 100. I create symmetric one. Okay, so this is my square. Then I create a circle, solid circle, x0, 0, radius 50. Okay, so the circle is also created. I can go operate, boolean, subtract, areas. So I select this. Okay, and subtract from this. Okay. Oh God. Okay, this is not going to happen. Okay, so what I will delete. Area, I say pcol. Okay, plot, multi-plot. This remains. Lines only, pcol, delete, plot, multi-plot. Nodes remain now. Key points, sorry, key points. Delete what? Key points. Pcol, deleted. plot, multiplot. Okay, everything is gone. So modeling, create rectangle by two corners, 0, 0, 100, 100. Okay. Circle, solid circle, 0, 0, radius 50. Okay, operate, Boolean, subtract, areas. Why the circle has not been created? List areas. There are two areas. Delete. No, again that is the problem. Okay, fine. Areas only, pick all, delete. Lines only, pick all, delete. Key points, pick all, delete. Plot, multi-plot. Again I do. Okay. So areas, rectangle by two corners, 0, 0, 100, 100. Okay. Circle, solid circle, 0, 0, radius 50. What is happening? Okay, this was the problem. So it was a zoom issue? No problem. Now operate. Operate, Boolean, subtract, areas. So from this area, subtract this area. Okay, so I got the required stuff. Then I go with the meshing. Now you can go with the co-connect option and then you can create whatever type of mesh you want. So I'm going to use default mesh. So whatever the mesh is available, that I'm going to use it. Okay. Now I'm going to apply loads, apply structural symmetry on line. So I just select these three. Okay. So all these are symmetric. Then I apply a pressure on line. So I apply only on one, constant value maybe 100. Okay, so it is moving down. Minus 100, it will move up. So that's done. Then solution, solve current LS. Okay. Okay, so here symmetry is there. So load has to be also symmetric. Pressure on line 100. Okay. Hope this solves the problem. Delete all loads. Okay. Okay. Now let's see. So I don't know what is happening. Maybe I just had made some mistake. So I just try to decrease the values only. Okay, so you try to do this. You try to perform this. So if any difficulty is there, just ask me the question. I'll tell you. So while drawing or maybe applying something, might have made the mistake. Okay. But this is what you are supposed to supply the what you say. The properties, and then in this way you have to find out. So rest of the things remains the same. There is no change. Okay. So just let me know whether you have understood this or not. Okay, fine. Okay, so little bit we'll discuss about the paper. Okay, uh, so that will help you. Okay, so these are the theory question. What are the different steps you follow in APM? So you are very aware. Prepare individual stiffness matrix, prepare global stiffness matrix, prepare force matrix, write APM equation K equal to M, then go with the elimination or penalty approach. So those are the things. Explain term shape function with properties. So shape function we have talked in detail. Sum of all the shape function 1, it starts from 1 at its position, other 0, and then also we also talk about some derivative stuff also. So those are the simple stuff. State the different types of analysis. So you are aware of static structural analysis, dynamic analysis, okay, modal analysis, harmonic analysis, thermal analysis. So you can write anything and you can brief any one of them. Then 3 bar elements assembled collinear. Node 1 and 4 are fixed. So 1 and 4 are fixed. Axial load of 10 kilonewton and 20 kilonewton applied node 2 and 3. Determine the displacement at node 2 and 3. Assume the length of each element as 1 meter. Stiffness as 1200 kilonewton, 1800 kilonewton, 1500 kilonewton for 1, 2 and 3 element respectively. So only the stiffness was different. So prepare individual stiffness, prepare global stiffness, write KQ equal to F, go with the first row, first column elimination, fourth row, fourth column elimination. It was a 2 by 2 equation, and you have to use Gauss elimination method compulsory. If you write directly from that onwards, you won't get any marks. Remember, always in examination, you have to compulsory use Gauss elimination method. Okay, program is given to you just to ensure that since we are conducting online lectures, so it will be a lot easier for you as we are solving a bigger problem. Okay, but in actual way, you have to use Gauss elimination method. If you don't use, you will get marks up to KQ equal to F, and whatever the further processing onwards you will do it, you won't get any kind of mark. Remember this very clearly. Okay, it was a very simple problem for 6 marks. Axial load, so this is a temperature based problem, we have already done it. So I don't think so anyone has an issue with this. It was a very simple problem for 6 marks. Explain the term plane stress formulation and its importance. Already I have told you many times. So there is a always one write a short note on. You can watch my lecture. There I have clearly said what is plane stress, what is plane strain. It is for 4 marks. Even I have tell you that for how much marks it is going to come and what are the things we have to write it. Okay, if you write that, you will get 4 out of 4. Triangular element with Cartesian coordinate, the shape function of interval. This problem, similar sort of problem we have solved. The problem is very easy, nothing else. Okay, so you can write x equal to n1 x1 plus n2 x2 plus n3 x3, then y equal to n1 y1 plus n2 y2 plus n3 y3. Okay, you can write down this, and n1 is zeta and n2 is eta, and n3 is 1 minus xi minus eta. Of course, the shape function at interior point value p is given to you, that is n1, n2, n3 is given to you, and you have to find the coordinate. It was a simple problem for 4 marks. Explain the term comparativity and completeness requirement in case of 2D element. So if you remember, I have given you SS Rao notes on the group. Okay, there I have explained it is related to continuity. Okay, so if you able to write C1, C0, C2 in terms of that, okay, so if first 2 is satisfied, that means it is completeness. If second one is satisfied, it is compatible. Something like this, those tasks were there. If you write those 3 tasks, 6 marks. Explain the concept of isoparametric, subparametric, superparametric element. Again, I have told you what do you mean by this. Isoparametric, that the shape function and the coordinate system, coordinate formulation is having same order of polynomial. Okay, so I can say x equal to n1 x1 plus n2 x2, and my displacement q equal to also n1 q1 plus n2 q2 plus n3 q. So displacement and coordinate, they are having the same formulation, that is isoparametric. Okay, if the coordinate is having higher and displacement is lower, then it is subparametric. Superparametric, if the coordinate is lower and the displacement is higher, that is superparametric. So one of the example isoparametric is the 1D bar. Then we have a CST element, then we have a quadratic element, then we have a 6-noded triangular element, then we have a 8-noded rectangular element, then we have a 9-noded rectangular element. These are all isoparametric. What is superparametric that we have studied? We have studied quadratic, then we have studied beam element. Okay, so all those were superparametric because their displacement relationship is of higher order, and a coordinate is having a linear one. Then determine the Cartesian coordinate of this. So this problem, whatever this problem is there, it is same as this. There is no difference at all. Okay, both are same problem. Only the here four shape function will be there, n1, n2, n3, and xi and eta is given to you. You have to calculate what is n1, what is n2, and such a simple problem for 9 marks. Okay, so it was very easy. Then explain the term substructuring and submodeling. Okay, so you can find out on internet. Okay, so substructuring is what we do in a discretization. Submodeling is like something like prototype modeling, what we are doing. So that we can also call it submodeling to reduce the completion time. Okay, compute. So already we have gone through integral 2-point Gauss quadrature method. I have also provided the notes for this in the group, so you can easily solve this. So these are the term aspect ratio, skewness, warp angle. This is related to CST we have studied. So if angle is more, if angle is smaller, then what is going to happen? I have taken example that if there is a one rectangle and if I mesh triangular element in two different fashion, then my accuracy is going to get affected, and therefore the terms like aspect ratio, skewness and warp angle comes into the picture. Okay, write down the governing steady state heat transfer equation. So it is a part of heat transfer you have already studied. Delta 2 T by delta x square plus delta 2 T by delta y square is equal to f of xy. That is my Poisson's equation. Okay, if f of xy is equal to 0, that is my elliptical equation on so on. Okay, find the temperature distribution in one-dimensional rod. So this problem we have solved it. Okay, this problem we have solved it. So it is in lecture 30. Okay, we have taken composite wall, and then we have taken on the other side there is a heat convection. Okay, so this is a similar one. So it is a one-dimensional. What is the meaning of that? This top end is insulated. This top, sometimes they will show you that this top end is insulated, and this water, that means cylindrical surface is insulated. The meaning is that my heat transfer is one-dimensional, or they will mention one-dimensional heat temperature distribution. That means my cylindrical surface is insulated. The meaning is same. So it is like composite wall, and the end is connected to H. So it is just like having a penalty approach. Okay, so H you have to add into stiffness, and additional force you have to apply H into T ambient on the force side. So it's like a penalty approach. The problem we have taken, it is on 30th lecture. Okay. Derive the FES stiffness matrix for pin fin. Okay, so this is I haven't taken. Okay, so you can refer the book. Two books I have put there. So it's a very simple one, because you know one-dimensional what you say stiffness derivation. So temperature is same, just H is added. So that modification you have to do. It's a very small. You could understand it's for 6 marks. So it's a small derivation. Okay, so the pin is showed is insulated on perimeter. Okay, so it is again one-dimensional problem. Okay, so they are saying it is insulated. They are insulated. Insulated means again it is a composite wall. Okay, it is a one-dimensional heat transfer. Q is coming from this. Say this problem also we have taken in 29th lecture, but I have taken as a composite wall. Okay, why composite wall? Assuming the heat transfer takes place through the wall only. That was the only idea. Okay, here in this case cylinder is there and they have insulated the top surface. That means there is no heat transferred in other direction, only in one direction. So it is as good as this is a composite wall. Then write down the consistent and lump mass matrix. So this is I have explained you for bar element. Okay, for plane stress this is out of syllabus. It is not there in your syllabus. Okay. Find the natural frequencies. So it should be beam element or bar element, and another two elements are there. A truss element is there. Truss element. Three elements are there. Bar element, truss element, and the beam element. Okay. CST element is not there. Find the natural frequencies. So A, 2A it is given. And if you remember, I told you that if the values of density and E is not given, assume suitable value and solve it. Okay, it was for simple problem, 10 marks, two elements. Okay, so only 2 degrees. This same problem we have solved. Same problem we have solved almost for 10 marks. Find the natural frequency of vibration using consistent and lump mass. So I have solved the problem with only consistent mass matrix, but at the same time I will also explain you what is lump mass matrix. So this problem you have to solve in a two way. First by consistent and second by lump. And most importantly, it is the only one element problem. Okay, so for consistent I am going to get 1 lambda, and for lump I am going to get 1 lambda, and this is for 16 marks. It was such an easy paper, so you should get more than distinction. It was such an easy paper regarding this. Okay, so I hope you have understood this. Just let me know whether paper was easy or difficult. Please reply. Okay, you can say difficult. There is no such thing compulsion that you always say easy. Whatever your feelings are there, you can reply, please. Easy. Okay, one I got easy. So all the problems we have solved. So there is no need actually to solve multiple problems. One problem is where enough. Okay, multiple problem means only the values is going to change. Okay, there is no requirement to solve additional problems. Through test itself we will go with the additional problem. So maybe in the next week also I'll conduct one more test. So I'm waiting for reply from all the others. What is about paper? Yeah, Roy, you have solved very nicely. I have seen your paper. Last time your performance was not that up to the mark, but yes, the way you are answering, my expectation was different. So yeah, this time really you have solved very well. Okay, Prashil also did very well. Abhishek also. ओके एनीबडी एल्स चलो यार 12 लोग इसमें आज लेक्चर में कम लोग हैं डिफिकल्ट बोल सकते हैं आई एम नॉट गोइंग टू पनिश यू okay fine so next week also I'll conduct the test but up to Friday try to submit the all your practicals okay and in next week one more exam we will take it so that will help you actually to understand that and then I'm going to also going to go with MCQs so actually you itself what you can do whatever the questions are available on internet whatever the questions are available on internet you can collect it and you can post me that with correct answer of course so I will create an MCQ and then you can also appear for that online test also okay so that will fill up your whatever the questions are available online and some of the question I will create from my side so that will also take care that whatever the question online are available that also we are doing and the question some of the question from my side I will be putting that we will be also doing okay so in this way we'll be preparing for both the stuff either for online exam also as well as for the offline exam also okay so since it is B and it is an elective subject so everybody is expecting that that this should be conducted offline. Okay, but depending upon the scenario, the decision will be taken whether to online or to the offline. Okay, so we will be preparing for the both the. Okay, thank you. You can start living.